Now we are looking to use the ratio test to assess the absolute convergence or divergence for the series, the sum from n equals 1 to infinity of 2n factorial divided by 2 to the n times n factorial. We're going to begin by looking at the absolute value of a sub n plus 1 over a sub n, where a sub n equals 2n factorial divided by 2 to the n times n factorial. And we have that this equals the absolute value of 2 times n plus 1 factorial divided by 2 to the n plus 1 times n plus 1 factorial times the reciprocal of a sub n, which is 2 to the n times n factorial over 2n factorial. Noting everything is positive, we can drop our absolute values, and we have 2 times n plus 1 factorial becomes a 2n plus 2 factorial. We have times 2 to the n times n factorial over 2 to the n plus 1 times n plus 1 factorial times 2n factorial. Now this 2n plus 2 factorial will give us a 2n plus 2 times a 2n plus 1 times a 2n factorial. In the top we still have a 2n times n factorial, and in the bottom 2n plus 1 we can write as a 2 times 2 to the n plus 1 factorial is n plus 1 times n factorial, and then we have a 2n factorial. Make sure I had parentheses in the top also. And we can look at canceling terms. The 2n factorials will cancel, the 2 to the n's will cancel, and the n factorials will cancel. So we are left with 2n plus 2, which actually can cancel if we notice that is equal to 2 times n plus 1. We can cancel that with the n plus 1, sorry. So we have a 2 times 2n plus 1 divided by 2, and again those 2's would cancel, so we're left with just 2n plus 1. So when we evaluate the limit as n goes to infinity of a sub n plus 1 divided by a sub n, we have the limit as n goes to infinity of 2n plus 1, which diverges to infinity. So by the ratio test, we can conclude that the sum from n equals 1 to infinity of 2n factorial divided by 2 to the n times n factorial diverges.